Gravitation is chapter number 8 of NCERT. It's unit number 6. In mechanics, this is unit number 6. So gravitation starts with the concept of Newton's law of gravitation. Newton's law of gravitation. So Newton's law of gravitation says if you have two masses, a body of mass, another body of mass m2, placed at a separation r, then these two bodies will attract each other due to a force which is known as gravitation force. Both the masses will attract each other with a force, and this force is known as gravitation force. These two masses will always attract each other, whether they are placed on the surface of Earth or they are placed anywhere in the universe. If you have two masses, they will attract each other with a force which is known as gravitation force. So masses attract each other due to gravitation force. Always attract each other due to gravitation force. So Newton's laws of gravitation gives the magnitude of this force. How do you calculate this force? So according to Newton's law of gravitation, this force is directly proportional to the product of masses. This is inversely proportional to the square of distance between them. When you remove the sign of proportionality, you will get this is F is equal to G m1 m2 over r square. This is Newton's law of gravitation. This G is known as universal gravitational constant. Universal gravitational constant. The value of G is it's 6.67 into 10 raised to the power minus 11. It's Newton meter square per kg square. This is the value of G. Now, there are certain features of characteristics of Newton's law of gravitation. The first characteristic is this law is valid only for point masses or for spheres. This law is valid only for point masses or sphere. Means you cannot use this formula for rod. If you have two rods, this rod is having mass m1, this rod have mass m2. Due to gravitational force, these rods will attract each other. But you cannot calculate that force using this Newton's law of gravitation. It's not valid for rods. We will see later like how to calculate this force for rods, but right now remember this thing, this is valid only for point masses or for spheres. You cannot use this law for rod or any other mass. That's the first characteristic. The second characteristic, this force is conservative. This force is conservative. It's a conservative force. Third, this force is central. Central means if you have two spheres, one of mass m1 another of mass m2. The force will act along the line joining their centers. One more thing. Maybe some of you must be wondering that I'm saying that two masses will always attract each other. Even on surface of Earth, if you have a mobile phone and a pen, then mobile phone and pen should attract each other. But if a mobile phone and pen are placed on your table, then they are not attracting. So the fact is, this is a table. Say a mobile phone is placed on the table and a pen is placed on the table. Both have masses. Its mass is m1, its mass is m2. They will definitely attract each other. But along with this mobile phone and pen, there is Earth. The mass of Earth is huge as compared to mass of M1 and M2. Earth is also attracting this mobile phone towards itself and this pen towards itself. The gravitational pull of Earth is very, very strong as compared to the pull of mobile phone and pen. They are this mobile phone and pen, they are trying to attract each other, but due to the very strong gravitation pull of the Earth, you don't notice any motion. You don't notice that this mobile is moving towards the pen. It's just due to the gravitational pull of Earth. If you remove this Earth, then this mobile phone and pen will definitely attract each other. Then there is superposition principle. So if you have two masses, then you can directly calculate the force between them using Newton's law of gravitation. But if you have more than two masses, let's say you have three or four or five masses, then how would you calculate force? Because Newton's law of gravitation can have only two masses. If you have a system having three masses, then to calculate force, you cannot write m3 here. There is no provision of third mass in Newton's law of gravitation. So how would you calculate if you have a system having more than two masses? So to calculate gravitational force for a system having more than two masses, we use superposition principle. Superposition principle says, say you have a mass m0, a mass m1, another mass m2, another mass mn. Separation between m1 and m0 is m1 naught, m2 and m0 is m2 naught, mn and m0 is mn naught. So this is r1 naught, this is r2 naught, this is rn naught. Separation between the masses m0 and m1, m2 and mn. So each of this individual mass will attract this mass m0. So you have this mass m0 and n masses m1, m2, mn. You're supposed to calculate force over this mass m0 due to each of individual mass. So superposition principle says first calculate force on m0 due to m1. This would be the direction of force because m1 will attract m0. When m1 attract m0, m0 will move in the direction of m. The name of the force we write is m01. F01 means force on mass m0 due to mass m0. Similarly, this m2 will attract m0. And this is the name of the force. It's F02. Force on mass m0 due to m2. Similarly, mn will attract m0. And the name of the force is F0n. So superposition principle says calculate force on m0 due to each of the individual mass and then vectorically add all forces. So according to superposition principle, net force on a given mass for a system of n interacting point masses is vector sum of forces due to individual masses. So to calculate force on a given mass due to a system of n masses, calculate force due to individual masses and then add them up vectorically. So the net force is vector sum of individual force, like vector sum of F01 plus F02 and keep on adding up to F0. This is basically superposition principle. So to calculate force for a system having more than two masses, calculate force on a given mass due to each of the individual mass and then add them up vectorially. Let's take an example on this concept. Let's say you have a system having three masses. You have a mass 2 kg. You have another mass, let's say 10 kg. And you have a body of mass 5 kg. Let's say separation between 2 kg and 5 kg, I call this as 10 meter. Separation between 5 kg and 10 kg is again 10 meter. I call this as mass 1, this as mass 2, this is mass 3. I'm asking you to calculate net force on mass 2. Say you're supposed to calculate force over this mass m2. So this mass m1 can attract this mass m2. It will attract this m2 in its direction, in this direction towards m1. The name of the force would be F21, force on mass 2 due to mass 1. Similarly, this 10 kg mass can attract this mass of 5 kg. The name of the force will be force on mass 2 due to mass 3. So basically, two masses, 2 kg and this 10 kg will exert force over this 5 kg mass. Is it clear, everyone? Fatma, Sania?
Yes, sir.
Not three. There are total you have three masses, but two masses will exert force over this 5 kg mass. 2 kg and 10 kg. The direction of force is clear. 2 kg will attract this 5 kg. So that means the force over this 5 kg due to 2 kg, it's towards 2 kg. This will move in, due to attraction, it should move in this direction. That's why this is the direction of force. Similarly, this 10 kg mass will attract this 5 kg mass, and this 5 kg mass will move towards this 10 kg. That's why the direction of force is this F23. Okay, the next thing. Now, can you calculate the magnitude of forces F21? For magnitude of force, you can use this F is G M1 M2 by R square. Keep on substituting the values. G is 6.67 into 10 raised to the power minus 11. M1 is 2 kg. 2 is 5 kg. Over the separation between them is 10, so it's 10 square. So it's 10 and this is 10 square. This 10 will cancel 1 square, 10 minus 12. So the magnitude of F21 is 6.67 into 10 raised to the power minus 12 is F2. Similarly, you can calculate F23. F23 is G, force over this M2 mass due to this M3 mass. So it's M2, M3 divided by r square. Keep on substituting the values. G is 6.67 into 10 raised power minus 11. M2 is 5 kg. M3 is 10 kg divided by 10 square. This 10 will cancel this square. So, and if I cancel this thing, 5 2s are 10. If I cancel it further, so this 10 will cancel the square. The 10 will left, 5 2s are 10. Then this is 23.335. So this is 3.335 into 10 raised to the power minus 11. So this is F12, F21 and F23. So superposition principle says first calculate force due to individual masses. So I have calculated F01 and F2, two forces, F21 and F23. So for net force on M2, for net force on M2, you can simply add these two forces. You can simply add these two forces vectorically, F21 and F23. You can add them up vectorically. So the net force will be vector F21 plus vector F23. Okay, can you guess the angle between these two forces, F12 and F21 and F23?
180 degree.
180. They're acting in opposite directions. So if vectors are acting in opposite directions, then instead of using the entire parallelogram law for adding, you can directly subtract them. You can subtract the smaller from the greater one. Which one is greater, F21 or F23? Just check which one is greater vector.
F21.
F21 is greater. This is 10 raised to 3.
No, F2, 3.
Greater vector. So you can write this as greater minus small. I'm repeating again. If you're adding two vectors vectorically and they're acting in opposite directions, then instead of addition, they will actually get subtracted. If you use the entire parallelogram law, then again you will see that they are getting subtracted. And when you subtract, we always subtract greater from smaller. So F23 is greater, F21 is smaller. So we'll subtract F21 from F23. So your F23 is 3.35335. 335 into 10 raised to the power minus 11 minus 6.67 into 10 raised to the power minus 12. You can even write this as this is 33.35 into 10 raised to the power minus 12. If I divide and multiply by 10, then this decimal will shift to the right hand side and you will get this negative power get increased by minus 6.67 into 10 raised to the power minus 12. So you can take this 10 raised to the power minus 12 as common and you are left with 13.35 minus 6.67 Newton. So this is the force acting on the wall. 33.35 minus 6.67 into 10 raised to minus 12. Is it clear?
Yes, sir.
Yes, sir.
Okay, so if I subtract them, then this will be 33.35, 6.67, 8, 6, 6, 26.68. So this comes out to be 26.68 into 10 raised to the power minus 2. Okay. After this system of 3 masses, let's take a system of 4 masses. This would be your home. This question will be for your homework. This is an equilateral triangle. So 3-point masses are placed on each vertex. 3-point masses are placed on each vertex. This is the centroid. On the centroid, I placed a mass capital M. Each side is A. Calculate force on mass capital M placed on the centroid. Okay, now can you guess the number of forces acting over capital M? How many forces are acting on capital M? The number of forces which over capital M. Just tell me the number of forces. Noor says 3, Sania says 3, Fazil 3, Fatma Sharif, Fatimatul Naja, and Rania 3. Yes, the total number of forces would be 3. If I call this as mass 1, I call this as mass 2, I call this as mass 3, and this as 4. And the forces acting on 4 are 1 will attract 4, 2 will attract 4, and 3 will attract 4. So 3 forces will act over this 4. So this is first force, that is force on mass at 4 due to mass at 1. This is second force, mass at 4 due to mass at 2. That's the third force, force at mass at 4 due to mass at 2. So these are the 3 forces which are acting over. Hint. This, all these separations are equal. This is R, because the separation of centroid from each of the vertex is equal. So this is R and this is again. The answer is 0. The net force over the capital M is 0. That's your homework question. You will try it. If you couldn't solve it, we'll do it tomorrow. After this, the next topic is gravity. See, what is gravity? Gravity is its gravitational pull of Earth. Gravity is basically gravitational pull of Earth. The gravitational pull of Earth is known as gravity. Means if this is the surface of Earth, so this is Earth. The radius of Earth is capital R. I placed a body of mass m on the surface of Earth. Separation between the center of Earth and this body of mass m is capital R. So the force which Earth exert over this mass m, this force will be F is G. Mass of Earth is capital M. The mass of this body is small m. And the separation between the body and center of Earth is equal to radius of Earth, that's R. This is R square. This is the force of gravity on a body placed on the surface of Earth. So this is force of gravity on a body placed on the surface of Earth. If you place the same body at some height, then the separation will change. Here capital M is mass of Earth. Capital M is mass of Earth. Capital R is radius of Earth. It's radius of Earth. Now, if I put this body to some height, like this is Earth, This is mass m. I place this body to some height h with respect to surface of Earth. The radius of the Earth is capital R. This is Earth. This whole separation, I say this is small r, which is r plus h. Then the force of gravity would be, in this case, it will be g mm. Let's see if body is at some height from surface of Earth. Then the force of gravity would be gmm by r square. And what is small r? It's r plus h. See, we always take separation between the center of Earth and the body. So you can write this as, this is gmm divided by, it's r plus h whole square. That's the force of gravity on the body. Gmm by r plus h square. Is it clear?
Yes, sir.
Yes.
See, gravitational force is for any masses. If you placed a mass on the surface of moon, then moon will exert some force over the mass. That is gravitation force, but it's not gravity. The word gravity we use for Earth only. The force exerted by Earth is gravity. If you place a body on the surface of Jupiter, then Jupiter will exert gravitation force, but that gravitational force is not gravity. Force is gravity only if it is between Earth and the body. So if you can remember Newton's second law. Newton's second law says if you have force, then you will certainly have acceleration. In a very simple form, this was Newton's second law. F is equal to mass into acceleration. This simply says if you have force, then you will definitely have acceleration. So if you have gravity, means gravitational pull of Earth, then you will definitely have acceleration due to gravity. So that is the next topic, which is acceleration due to gravity. Acceleration due to gravity. So acceleration due to gravity is simply acceleration due to gravitational pull of Earth. In fact, the name itself defines it. This is the acceleration of a body due to gravitational pull of Earth. Due to gravitational pull of Earth. That's acceleration due to gravity. So if I placed a body, let's say this is Earth. The radius of Earth is capital R. The radius of Earth is capital R. I placed a body of mass small m on the surface of Earth, and this is Earth. Mass of Earth is capital M. So the force on mass small m placed on surface of Earth. So if I place a mass small m on the surface of Earth, so the gravitational force or gravity on this small m will be, this is F, which is G capital M small m divided by R square. That's the gravity. Then acceleration due to gravity acceleration is represented by A, but since this acceleration is due to gravity, so we represent it by G. The general formula of acceleration is force divided by mass. So you can write this as, this is gmm by r square, I divided by m. So m will cancel this m. So your acceleration due to gravity is gm by r square. So this is the acceleration due to gravity, which is gm by r square, capital R square. Here m is the mass of Earth, which is 6 into 10 raised to the power 24 kg. Capital R is radius of Earth. And the value of R is 6400 kilometer. If I convert this R into meter, then it comes out to be 6.4 into 10 raised to the power 6 meter. That is the radius of Earth. If I substitute all these values here, like capital G is 6.67 into 10 raised power minus 11. M is 6 into 10 raised to the power 24 kg. Capital R is 6400 kilometer, or in meter, this is 6.4 into 10 raised to the power 6 square. If I solve these things, you will get G is 9.8 meter per second square. So this is the value of acceleration due to gravity for a body placed on the surface of Earth. But remember, this is acceleration due to gravity on surface of Earth only. On surface of Earth. So if you place a body on the surface of Earth, then the value of acceleration due to gravity over this point will be 9.8 meter per second square. There is one interesting characteristic of acceleration due to gravity. See, capital M is mass of Earth, capital R is radius of Earth. It's independent of the mass and shape and size of the body. Means whatever be the mass of the body placed on the surface of Earth, you can place a pen or you can place a truck. The value of acceleration due to gravity will be independent of the body. It will be 9.8 meter per second square. So acceleration due to gravity is independent of shape and size of the body. It is absolutely independent of shape and size of the body. So this is the value of acceleration due to gravity if a body is placed on the surface of Earth only. Now, for your school exam, this is an important topic. You will get at least one question from acceleration due to gravity. But that question will not be on this thing. The question you will get is on the variation of acceleration due to gravity. See, the value that we have calculated here is for a body placed on the surface of Earth only. But if you place body at some height above the surface of Earth, or if you take this body at some depth below the surface of Earth, then value of acceleration due to gravity will definitely change. And the questions that you get are basically on variations. Variation of acceleration due to gravity. Variation of acceleration due to gravity. The first variation that we get is from height. That how will the value of acceleration due to gravity change if you take body to some height. So if this is Earth, if this is Earth, the radius of the Earth is capital R. And I take this body of mass m to height h. The separation between the center of body and height h is r, which is r plus h. So the force of gravity on body The force of gravity is this, it's G by R square, or this is G by R plus H square. This is the force of gravity. For acceleration due to gravity, see there's very minute change. Huh? Instead of R, you are using R plus H since you are taking body to a height H. I call acceleration due to gravity as G prime. I'm not using G because G is fixed that its value is 9.8 and the term G is fixed for a body placed on the surface. But your body is not exactly on the surface, your body is at height H. So I'm not using G, I'm using G prime. It's force by mass. So it's GMM by M R plus H square. So this M will cancel this M. You will get that your G prime is GM over its R plus H whole square. It's GM by R plus H square. So we can write G prime as, you can leave your calculations here. This is the value of acceleration due to gravity at a height h, but it's better if you can convert this in terms of small g. But g is gm by r square. Let's call this as equation number 1 and I call this as equation number 2. See this g, when I write gm by r square, I'm repeating again, this means that body is placed on the surface of earth. If you're placing body to a height h, then it won't be g, it would be g prime. I'm trying to convert this g prime in terms of g because value of g is known, that g is 9.8 meter per second square. To simplify calculations, I can write this as, this is gm by r plus h square. So let's take r as common. If I take r common, then this will be 1 plus h by r whole square. Is it clear? Everyone, I just take this r common. If I take r common, that means I'm dividing both the terms by capital R. So I take r as common, I divide the first term by capital R, so it becomes 1. And if I divide this h by capital R, it becomes h by r. This square, so you can write this as, it's gn over r square. Then this is 1 plus h by r whole square. Then you can write your gm by r square as small g. So this is g over 1 plus h by r whole square. That's the value of g prime. So this is how you can write your g prime in terms of g.